Okay, welcome back to the second solder sample that we're going to be doing today, and that's a right angle. A right angle will allow you to create something that is hollow and have a container. It will also give you a bezel for a stone setting project, which we will be doing this quarter. What we're going to work with today is a 1-inch square of copper and a piece of brass. And I could just put this right in the middle and solder it like that, but how am I going to get it to stand up? So what I might want to do is take my interlocking tweezers and use that as a mechanism to hold it up. Okay, so if your design works around a straight line, that's how you would do it. I'm going to be different, and I'm going to put a bend on it because they're options, and now it stands up on its own. The reason why I'm doing that is you need to know that the interlocking tweezer is going to be what's called a heat sink. So just as you think about the size of the metal and the type of the metal, if you're using interlocking tweezers, so much of the heat off of this brass piece is going to travel up onto the interlocking tweezers, and so you're just going to need to be aware of that. Taking that out of the equation, it's going to be a little bit easier if you bend your piece and make it stand upright. Okay, so I'm going to take my Scotch-Brite pad. I'm going to scrub where the piece is going to sit. I can scrub this way, but another thing that's nice to do is to just take a piece of sandpaper and sand that bottom edge flat. So this is some like 320 sandpaper. This is going to guarantee that I've got a good fit on there. So now I know that that's a clean piece of metal that's touching a clean piece of metal, and I'm ready to solder this. Okay. I actually calculate things. I guess it's the part of the scientist in me, but I calculate this. It's like, okay, this is like a little less than half of what the copper is. So that's going to mean that this is going to heat up faster, even though the copper heats faster. Okay, so you take that into consideration. And then if I have it sitting upright, heat rises and the fireboard is going to take some heat away. So I'm going to have to find a way to get more heat on the bottom piece. And normally what we do is we use a tripod, but today I want to try using this brick because it's got air cavities in here, and it might allow me to solder this without having to use a tripod. And I will be showing you guys how to use a tripod as well. But I'm going to bring this over and I'm going to set it up here, and I'm going to flux my piece, and I'm going to flux the bottom of this, and I'm going to set them together. This is where, when I start learning how to solder, I immediately started feeling like that kid that was using building blocks and making stuff. So I want you to be thinking about all the other possibilities of things you can do with all these parts that you're going to stick together. I'm going to take and I'm going to cut some solder again. And I'm going to remember that the solder travels in and not out. So I'm going to want to put a piece of solder on both ends. And I like to have a little bit of flux on my solder. And so I'm going to pick that up, and I'm going to put just right on the end there. And I'm going to just take a second one, and I'm going to put it on the other end, and that's all I'm going to do. One of the things that you want to remember, and you'll forget in the beginning, but you'll learn right away when you have to clean up the solder, it's much easier to clean up the solder on the outside of a curve than it is on an inside of the curve. So that's why I'm putting the solder on the outside, because it'll be easier to clean up. And I will keep reminding you of that. So now I've got to start my torch, and I've got to start heating this. I'm going to come in from the top, and I'm going to heat around the outside. I'm going to watch the flux go clear. If it's clear just on the upright piece, I know that I might not be able to solder it on this honeycomb board. But I'm going to then start really focusing just on the base plate. And so what you want to watch for is first what happens to the flux. And if it turns white at the same time, you're in good shape. If it's turning white on one edge and not on the other, then what you want to do is focus the heat on the one that hasn't turned white. So I'm going to come in, going to heat around the outside. I like to heat up slowly because sometimes the water will bubble and it'll blow my flux away. And then my solder chip will go popping off. So you notice that I'm coming in very gently, heating around the edge. And I'm not even really heating the top. And I can see that it moved because of the water. So I'm going to push it back. Maybe. And that one stayed in place. So as we're heating this, that one popped too. That's because I needed to show you how to push them back. At a certain point, the flux turns white. It's like a glue, and I can't push that back. So I'm going to just keep heating until the flux starts to turn clear. Did you notice that it was white and white on both? So I feel like I'm managing my heat control. And now that the flux is turning clear, I can push that piece of solder back into place. If I heat up the tweezers too much, it'll stay on my tweezers. Okay, so the flux is turned clear on both. You notice that I'm heating directly down onto the plate. And I'm not really heating the upright piece much at all. The flux is starting to turn clear. So that's the time for me to target the joint. And that means come in with my blue cone and work along the back side. I'm going to pull that solder through. I'm going to see that solder flowing, and I think it's done it, hasn't it?
Yep.
Okay. So I work from the back side because we're working with metals that conduct heat. And I can see, uh-oh, it didn't. Doggone it. Okay, stay with me on this. I'm going to take one more piece of solder. Going to put it back down. Can you see that it's still, the metal is still clean where I was soldering? If this were dirty, I would have to pickle it, but I'm going to try to get in and solder this. And this is why I use tripods. But this was a good experiment.
So this is showing that the bottom wasn't hot.
Yeah, it wasn't hot enough, so the solder ran up. So I'm going to come in and I'm going to heat that puppy. And you can actually get the solder to reflow because it will go wherever it's the hottest, even if it's flowed before. So see how hot I'm getting that? And the camera's probably seeing it better than me because I'm from the back side.
Yeah, it looks like it's gone now.
There we go. Did you see it? And it almost looks like mercury when it's flowing. So don't get discouraged if it doesn't go right the first time. What you want to do is diagnose what you did wrong and then go back at it again. And that was one of the things I really loved, was that I could fix my mistakes. So if you look at this real closely, you can see my solder went up. My solder went up. But I've got a beautiful line running here. And when I turn it around, I can see that the solder has penetrated all the way through. So I've got a good angle, or I've got a good angle joint on here. And I'm not going to be able to bend this tubing, or bend this sheet much, because I've got now an I-beam. And then I also have some beautiful oxides here that some people like to keep. But we're going to toss this in the pickle. And I'll show you guys how to clean up where I've got some solder. All right.